Welcome to the Bath Royal Literary and Scientific Institution. Tonight's talk is the second of 3 talks commissioned to complement the current BRLSI exhibition entitled Riches of the Earth. Our first speaker, Bennett Harley, outlined the geopolitical risks that countries without access to these minerals would have as they became more important as we want to have a cleaner, greener environment. The importance of rare earth minerals was highlighted recently on Radio 4 in the Start the Week program, and our speaker tonight is going to address some of the issues of mining of these rare earth minerals. We are pleased to have Karen Hudson-Edwards, who joins us from the Camborne School of Mines, where she is the professor of sustainable mining, to discuss the extraction process in this new age of minerals. Can we welcome Karen? Right.
Well, thank you, Betty, for that introduction, and thanks very much to the Bath Royal Literary and Scientific Institution for the invitation to come. I haven't been to Bath for many years, so it's lovely to come back. So I am currently professor in sustainable mining. I've been doing geology for about 30 years now. I'm Canadian, you might detect in my accent. So I trained as a geologist in the 80s, when really there were only 2 choices of career. Either you went and worked in the oil industry, or you went and worked in the minerals and mining industry. And I found minerals much more exciting, so that's what I did. And since I've studied long ago, the world of minerals and mining has really changed. And I hope you're going to see that with what I'm going to tell you today. So let's move on. So just to get us thinking about mining and minerals, and I just included these images. So if you just have a sort of quick look at some of them, and then I'll just go through what they are. And hopefully they're quite interesting images, and they give you something to think about, both in terms of the beauty of King Tut's mask, but maybe also the footprint of the mining in St. Austell. This is down in Cornwall, where I live. So these are all, like many things, related to mining. The gold in King Tut's mask would have been mined sometime in the past, maybe by slaves, we don't really know. Even today, mining can leave a footprint, like the old clay working pits and clay quarries around St. Austell. But we use these landscapes to teach students. So these are our Camborne School of Mines. Oh, I forgot about this thing. Oh, no, not that one. Wrong one. Where's the, there we go. These are our students from Camborne School of Mines, and they're studying some old mine history in Batalic in West Cornwall. And these are remnants of a buttle pit. And these Okay, we're there. Okay, so the things I'm going to talk about are mining and this thing called the Green Revolution, the impacts of mining, which we've alluded to already, then go on to talk about this new idea, a new paradigm of sustainable mining, and then think about what's happening in the future. So if we start with mining and the Green Revolution, you probably heard a lot about net zero carbon, and these are some of the banners and documents by many of our governments in Europe and elsewhere saying how we want to get to something called net zero or net zero carbon. And this is in the recognition, of course, that the climate change we're seeing now and the global warming is likely and has been proven to be caused by carbon-based gases in the atmosphere, particularly carbon dioxide and methane. And so many governments have recognized this, and they're realizing that they need to stop increasing the emissions So aiming to get to net zero. So recognizing we're still going to be putting probably carbon into the atmosphere, but let's then devise ways to take it out at the same time. So the overall effect is zero. So it's not just the UK. The UK is aiming for 2050 for this. Other governments are a bit sooner. Canada's 2050, others are 2040. But, you know, in the next 30 or so years, we're going to see, hopefully, this big move to net zero carbon emissions. And this has had profound implications for minerals and mining. So what it's meant is the technologies that we're seeing in the 2000s are very different from those that we saw in 1700. So in 1700, we burned a lot of carbon-based fuels, coal and peat, and maybe we use windmills to generate some power to grind flour and so on. But over time, and it's not that long, over the last 300 years, things have changed enormously, largely because of our industrial revolution here in Britain and going into the more technology-driven environment that we see today. So in the 1800s, we started to see trains and electricity. And what that meant is we needed a lot more elements from our Earth to make these technologies. And as we moved into 1900, a lot more cars, airplanes, and again, the number of elements, chemical elements that we need is growing. And here we are in 2000, and moving forward, we're starting to see even more elements required. And that's because our technologies are getting more sophisticated, and the components of them require not huge amounts of all these extra elements, but significant amounts of these elements to make them go. So for example, we've heard about rare earth elements. We need those in electric cars because we need them to drive the magnets that make a lot of the components work in cars. We need lithium for batteries for electric cars. We need cobalt for those batteries, and so on, plus all this list of elements that we see here. And what we're seeing is an increase in demand for all of these elements. So it might be a little hard to see. This is from a paper published 2 years ago, showing that we've got on the x-axis going from 1800 to about 2100. Sorry, 1980, I think it is. And you can see that the graphs go up steeply. So the demand is increasing really, really steeply for everything probably except lead. And so lead's going to go up and then go down again. And that's because we recognize that lead is a very bad toxin for humans, particularly young children. If we get lead into our system, it can cause brain problems, and it's not very good for us. So I think that's probably why the decrease in lead is happening, but certainly increases in copper, iron and steel, everything that we see. And a question I often get when I give these talks is, well, we've been mining ever since humankind has been on this earth. Don't we have enough metals and things like this to recycle properly? And that's a great question. And the answer is no, we don't. There's a couple reasons for that. One is that the recycling that we have just isn't good enough at the moment. It's very difficult to extract a lot of these metals, especially the ones we use in small quantities, from the things we make. And part of that's because actually the way they're made makes it really hard for them to be taken apart. They're made too well. So that's one aspect. The other is the demand. Copper is a really good example. The demand is increasing so much that even if we recycled all the copper that's ever been mined, we still wouldn't have enough moving forward. And we need these metals for this green technology or this green revolution we're seeing. All these, the wind turbines, the electric cars, and so on, require not only these, what we call major metals like copper and aluminum, but some of the trace elements like rare earth elements. And so the demand is really there. Now, of course, demand is related to what people want. So, part of it is we don't have enough. Part of it is that we're used to good lifestyles and we like to have lots of things, maybe not the people in this room, but, we're used to having a lot of things. So in parallel to, mining, we need to think about consumer demand, which is more of a social issue. So if you're a geochemist like I am, you're interested in the periodic table of elements, and this is a form of it. And what I've circled, don't worry about the different colors, but what we circled are the different types of elements in terms of how we describe them. but actually in the shaded color, they're the elements we require for the green revolution. And you can see that almost the whole periodic table is now going to be lit up because our demand is so great. So where do we get these from? Well, I've mentioned recycling, and that is certainly one way, and we're trying to improve that, certainly as we move forward. But there is a slogan that miners have, and it's, if it can't be grown, it must be mined. And it sounds a bit jargony, but it's true. Everything in this room that isn't from oil, so some of the things are, the plastics are from oil. If we have some water, maybe that's organic, but everything else had to be mined or is going to be mined at some point. So even though we're in this green revolution and we want to, produce clean energy and reduce our carbon footprint, to make those technologies, we still need to mine. We just don't have enough yet, and mining is the only way that we can do it. So we are moving, I think, from the age of oil. So we're trying to get away from fossil fuels to the age of minerals. So minerals, there's no picture of a mineral up there, but actually minerals are the building blocks of rocks, and they contain all the elements that we need. And so we are moving to an age where we need to mine more minerals to get all the elements that we actually need. So why minerals? Well, here's an example of one type of mineral. And I should point out the lovely collection of minerals you have downstairs here. They're absolutely stunning. And there's actually a whole case devoted to copper minerals. And I'm using copper as an example here. So do have a look before you go out. They're fantastic. There's even one from Cornwall, which is great. At least one, I think, maybe two. But here's chalcopyrite. So in chemical formula, it's copper iron sulfide, and it's the main ore of copper. So if you hear about a copper mine, it's normally this mineral that they mine. And what they're trying to get out is the copper. So the iron, it's useful, but they can get iron in other ways from other types of minerals more easily. The sulfur is a bit of a contaminant because it can make sulfuric acid. So they're after the copper. The people that extract and then go through the mineral processing are after the copper from this mineral. But now that we're entering this, what sort of new age of mining, we think about these minerals in another way. And so if we look at the atomic structure of chalcopyrite, this is what we call a ball and stick diagram. It's not exactly how the atoms look, but it gives you an idea of the different types of atoms in the chalcopyrite. So normally the yellow would be the copper, but we know that if there's any silver, Ag, around, that silver can also substitute for the copper in that mineral. So it can be a source of silver. Similarly, the indium here is often can go in the site where the iron is. So it can be a source of these trace metals as well. And I think the tellurium can go in for the sulfur. So minerals like these are becoming not only valuable for copper, but valuable for other metals as well. And so it's opened a whole new field of looking for these other elements, and it gives more value to the minerals. So minerals to me are the building blocks, as I said, and they're so important to understand because you can then start to plan, well, if I've got a chalcopyrite ore, I'm going to look for these other elements and perhaps increase the value of my mine and contribute to these green technologies even more. So there they are, the extra elements. Okay, so hopefully I'm starting to convince you that we do need mining at the moment, but I think it's important to look back at mining in the past and think about it right now and what's going on in mining. So the first thing I'm going to show you are the UN Sustainable Development Goals. There are 17 of these, and they cover things like life and water. So it's difficult to read from here. Well, climate action is one of them, peace and justice. And actually this plot that people have made has tried to link mining to these 17 Sustainable Development Goals. And above, they put the goals that mining can enhance, actually. So it can enhance quality education. Without mining, I don't think we'd understand our Earth as well as we do. And that's because miners have gone underground. And by looking underground, we can get a much more three-dimensional view of our Earth and learn a lot more about it. So actually mining has given us so much knowledge in many, many ways. No poverty. So that's got a star because I think it could be above or below. But in areas, where mining occurs and is done properly, it can contribute to wealth of communities and so on. But there's certainly areas under the horizontal line where mining has not had such good impacts in the past. So life and water, there's no question that mining has contaminated, polluted water bodies, both by throwing waste into the water or letting other chemicals get into water. And so all of these parts, life on land, peace and justice, certainly mining has had negative impacts. And we hope most of those negative impacts are in the past. But still today, there are areas where mining has what we call not positive or negative effects. But what mining companies are doing, and that's where I'm going to sustainable mining, is to try and take most of these, address them, and try and move them across that horizontal line into the enhancement area. So I'll come on to that in a little bit. So here's some of the upsides or the positives of mining. So I've already mentioned that really, if we want these things that the chairs and the computers and the iPhones or phones that we use, we need mining to provide the metals, the minerals that we use to make these tools, buildings, everything, you name it. It does provide a lot of jobs. So they can be very high-paying jobs. A lot of our students from the Camborne School of Mines go down to Australia and do very well at various types of mining jobs. It can contribute to the gross domestic product and to the economies of countries where mining takes place and support cultural development. So if you read stories about old mining towns everywhere in the world, often they were real hubs of culture because they had a population there that worked very hard, but wanted to go to plays and literary events and so on in the evening. So there's a place I went to before Christmas called Kalgoorlie in Western Australia. It started about the late 1800s. And again, it had dance halls and stages, and it was very culturally aware. So there's a lot to do that mining has helped promote. I've already mentioned scientific knowledge. And also, I think mining can drive sustainable development and the green revolution as well. But I think we need to acknowledge that mining often has a number of downsides. There's no question about that. And a lot of people I know think mining is dirty and bad and it should be stopped. And I think we really need to acknowledge these negative aspects. So we know that mining can create enormous amounts of waste. And the reason for that is, if you think about mining metal, the big copper mines these days are mined at about 0.5% copper grade. So that means that they're mining a huge amount of rock to get 0.5% of copper out of that rock. So, 99.5% is waste. And the waste issue is massive, not only in volume, but for the mining companies, because they need to deal with that waste. And sometimes the waste that is managed, but sometimes it isn't managed. And sometimes the waste contains nasty things like arsenic or lead, and those things might get into the environment. So that is a huge issue. And the waste can cause pollution of water, soil, and air, and so can the mining activities. We know there's very noisy when they blast, there can be dust and so on. When mine footprints expand, they can deforest areas, and we still see that happening today in many places. And that can lead to a loss of biodiversity as well. I've shown you the picture of the clay tips around St. Austell, and we call that a footprint. So the mine has left something on the surface. And here's a site in Cornwall called at Heartlands near Camborne in 1900. And really the whole landscape was mines and chimneys puffing out smoke, not very nice. It doesn't look like that today, but this sort of footprint is very typical of a mine and what a mine can leave behind. And then on the people side, which has really been ignored a lot up until quite recently, is we know that people in the mines aren't necessarily treated that well by the mine owners. So violence, displacement, exploitation, not safe conditions, and so on. So I think by acknowledging these and trying to understand what are the impacts, what are the scale of the impacts, we really are starting to do something about that to try and turn things around. So, as I said, I think there's a change going on in mining, and it's probably been going on for a while, since really the idea about climate change started, actually. At that time, I think miners started to look at what they were doing as well. So I'm going to pick out some of the highlights that I think are happening that are really causing big change in mining. So the first is, first of all, groups recognizing the need for mining. So the top line there that you see, the World Summit on Sustainable Development in 2002, so that's a long time ago, 21 years ago, really highlighted the importance of mining metals and minerals extraction. So it wasn't saying we shouldn't have it, it's saying we recognize that we need it. But these groups have come along to say, okay, we understand we need mining, let's think about doing it a lot better so we don't have all these negative impacts. So a lot of groups have sprung up. This is a first one. It was a Canadian one called Towards Sustainable Mining, setting out some of the principles by which mining companies should really aspire to get towards, to not be polluters and not be exploiting people and so on. And since then, many have come up. There's the ICMM, which is the International Council of Mining and Minerals, Mining with Principles document. And there's alliances that a lot of the companies will join and then promote safe practice, good practice. Here's one, the Alliance for Responsible Mining, Initiative for Responsible Mining Assistance. So I think these were the first kind of, let's rethink our industry that was starting to come along. This one was about 1986, I think, and then 2000. And since then, there are more societies and more groups certainly coming along. So that's one of the things. And then the next big one that I think is as a result of accidents. So we know that accidents in any activity can cause change. So you have an accident, you realize something's not good. So one of the big things that happens in the negative side, I suppose, with mining are these things called tailings dam failures. So tailings are a type of waste. It's like sand size or less. And it's the leftover waste after the ores have been processed to remove the valuable stuff. So tailings are a waste that are considered not to be valuable. And they're very voluminous. So it's the biggest waste stream by volume that mining produces. And in the past, tailings were discharged to rivers and oceans. And that was great. You thought, let's put it in the river, it'll take it away, it's fine. But of course, we recognize that's not a very good thing to do anymore. So a type of construction called a tailings dam or a tailings impoundment has been used for decades now. So this is one in Canada, in British Columbia. And here's the before accident event where the tailings were discharged to this tailage storage facility that was dammed all around the outside. So this is a good model if it works and if the dam is safe. But in many cases, the dams fail. Not a huge number, but you can see 110 recorded failures since 1960. That's recorded. There are probably many, many more that we don't know about. But sometimes they fail for various reasons. Sometimes it's a natural event like an earthquake. Sometimes it's the mining company filling up the dam too quickly and the dam not being able to handle it. In this case, this dam was built on a series of glacial deposits, and one of them slipped and it caused the dam wall to fail on this side. So this is in Mount Tupali in 2014, this was the biggest by volume tailings dam failure at the time. So this is the before picture, this is a NASA image, and here's the dam, and then this is the after picture. And so this part of the wall failed, the tailings spilled out, were blocked by this lake, and then went through this little creek, which you can barely see on here. So this was 1 meter wide to begin with. Afterwards, it was 100 meters wide and it scoured down to bedrock. And most of the material ended up in Quesnel Lake. So it was a big event in Canada. It made global news, and these types of events are not very good for the mining industry because it causes lots of problems. So this didn't kill anybody, but it killed all the fish. It caused some water problems with Quesnel Lake. But fortunately, the tailings didn't contain anything toxic. So it was mostly a physical effect. But you can have events that cause loss of life. So the game changer I see is another failure that happened a few years later. So this was in January 2019 in a place called Brumadinho in Brazil. These were iron ore tailings. And you can see, again, this is the aftermath of the dam spill. Iron ore tailings are iron colored, so they stain everything. And it had failed up here and then spread through this river system for about, I think, 80 kilometers. So the whole area was very affected. But what was different about Brumadinho is that the tailings were built just the dam was built just upstream of the office and the canteen. And when the dam broke, it went right through the buildings and killed a lot of the workers. So 230 people died as a result of this. And it really left a mark on the town because it killed people in the mine and also in the downstream town. And this was the point, I think, when really people really woke up. And what happened was the Church of England were so, well, appalled by this and the tragedy that it caused, that they looked at their portfolio of investments and they said, okay, mining companies, if we're investing in you, can you write to me and tell us what you're doing about your tailings dam safety? Because we don't want this to happen again. So that's the first thing they did, this investor initiative on mine and tailings safety. They did that in collaboration with the UN Environment Programme and the International Council on Mining and Minerals. They got a pretty good response, so about 60% of the companies responded, and it became clear that the safety wasn't as good as it should be. So after that, they got together and wrote a review on what they'd found, and that was published. And then they got a lot of experts together and they developed the global industry standard on tailings management. And for a group of academics and industry people, this happened remarkably quickly. The spill was in January 2019. This was published in, I think, about a year and a half later. So they worked extremely hard to change things. And this is the first global standard on mining that there ever has been, and it's causing a sea change in company behavior. Companies know that the investors are watching and they have to be accountable, and people just don't want these accidents anymore. So this is one of the big changes we're seeing, that mining companies are really becoming accountable and changing their safety behavior. So that's one of the game changers. The other one, I think, is what your original speaker spoke about, and it's where a lot of our precious minerals and precious metals are located. And you can see China is the big place. So the periodic table that I showed you with all the elements we need, 90% of them are mined or processed in China. There are other countries that contribute. Oh, sorry, that's China, not Russia. There's China. There is other elements in other countries. So there's niobium in Brazil, there's platinum in South Africa, some lithium in Australia, but by far, China is the dominant power. And I think people are quite worried about that. They don't want everything in one place. We know we need a lot of these elements to make our green technologies, but if we have to rely on China, they could suddenly say, no, we need everything for ourselves. You can't have any. And so there's a big rush now of looking for mines all over the world, new mines to mine these elements. But the thing is, those mines have to be done well, or people are not going to let them happen. And this is where we come on to sustainable mining. And this is where things are going. So there are 5 corners or 5 key elements about sustainable mining, and I'll go through each of them in the next slides. So the first pillar or corner of sustainable mining is the economics. And this is actually an important one for lots of reasons. One is that while we need to hold mining companies accountable, we need to recognize that they are businesses and they need to make a profit. They're not in the business unless they can make a profit, but they can do that while still being sustainable and responsible. And they're recognizing that, and they're changing a lot of their business models to make sure that they are doing things the right way, mostly. But the other thing is, again, a sea change in the way people think. So I mentioned mine tailings as being a big waste stream, and they're stored in these dams. And now people are thinking, well, let's think about that and turn it on its head and think maybe it isn't waste, maybe it could be a resource. And so the companies and also other new companies are thinking, well, let's look at those tailings and see if there's any potential for some of these elements. And the reason for that is when the tailings were produced, maybe they're 100 years old, maybe indium wasn't valuable, or maybe beryllium wasn't valuable. So there's a lot of work in reassessing tailings. And in fact, tailings are now being reprocessed and mined to get these valuable elements out. So it is just this change of thought and thinking of a new business model to try and not only clean up the tailings problem, but also get some value out of that. So that's sort of on the metal side. The other thing is to think of, there's a lot of material in tailings which doesn't contain the metals, but can contain silica and aluminium and building materials. So there's a big move to think about using that part of the tailings to make things and to replace cement, which is actually very carbon intensive and generates a lot of CO2. So we're seeing a big sea change in that as well. So the companies are trying to be responsive to this. The next thing is the environment. And for a lot of people, this is the biggest issue around mining. So there, as I mentioned, there's lots of issues with mining. One of them is this thing. So acid mine drainage is a particular type of water produced by mining processes, but also by the waste that mines produce. And you may have heard of a mineral called fool's gold, which is actually pyrite. And a lot of mine waste contains pyrite, which is a very nice mineral if you have it in your collection. It's little cubes, very nice. But if you leave pyrite out in a big waste pile, like we have in many parts of the UK and globally, it reacts with water in the atmosphere, oxygen in the atmosphere, and believe it or not, there are bacteria that love to live in pyrite. But those three together can make this water, and it's very acidic. It's basically sulfuric acid. And because it's acidic, it leaches out all the nasty things like arsenic, antimony, and so on. So acid mine drainage, this is an old mine in Wales. I think it's Cymystwyth mine in West Wales near Aberystwyth. And a lot of our old adits leak acid mine drainage. So it is a big problem. However, because we've been working on it and we're getting to understand it now, we have ways to treat it. So this is a mine water treatment plant in Cornwall at Wheal Jane, and they use quite a simple technology. So we have a lot of acid mine drainage in our underground old mine adits in Cornwall. They pump that up, they put air into it, and they add lime and some coagulant, and that makes a sludge that they store in a tailings dam for later use. And then by making that sludge, the sludge takes all the bad stuff out, essentially, and the pH is raised. So after they've treated, they can discharge the water back to the river after the Environment Agency has checked it. So we do have the technology to do things properly, and we are doing these, we're remediating sites much better than we used to, and companies have to pay and sometimes governments pay. So that is improving. The other thing is we know a lot more about what we can do with old landscapes that we're mining landscapes. And there's a colleague of mine in Cornwall that's written 2 books actually called 100 Things You Can Do with an Old Mine. So there's 200 things now. So here's one of them. This is the Eden Project in Cornwall. And it's a good example of mine land remediation. It's an old pit left over from clay mining. And they've put the Eden Project in that pit and they monitor it and manage it. And that's a great use. But there are many, many others. We talked about a quarry used for swimming. So there's loads of things that old mine sites can do. We also know how to reforest a lot better. And actually there are mines now that are operating, but build forests next to them at the same time. Not many, but they're really getting to the idea that they don't have to wait till the mine is finished. They can do things as they go along. The other thing is to harness the natural environment to help us to remediate. So these 2 examples are examples of those. I'm back in Cornwall again, sorry, lots of Cornish pictures. These are our old engine houses in Cornwall. We have a World Heritage Site, mining landscape World Heritage Site. So these are protected, but fortunately the landscape's adapted. So this is gorse, and our heather in Cornwall is very well adapted to growing on polluted soils. And that's a good thing because it stabilizes the waste and they don't blow around and cause problems. And then there's a whole field of geology, which wasn't around when I studied. It's called geomicrobiology. And this is where people can train to be both microbiologists and geologists at the same time. And they can look at the microbes. So these are bacteria. This is a bacteria called NT26 in Australia that loves to live in arsenic contaminated areas. It's very, very happy there. And so if we can look at these bacteria and other microbes, make sure that they're living in good places that might be contaminated to us, but not to them. And we can use them for bioremediation as well. So I'd say we're really getting really well advanced in the environmental side. The next one is called resource efficiency. And what this means is we know traditional mining generates a lot of waste. Can we mine in a different way that doesn't generate so much waste and also doesn't leave such a footprint? So here's an example of something potential, we hope. So this is a typical way that lithium is extracted. So in the salars, the lakes in the high Andes and some of the high areas in the US, this is in Bolivia, there are lakes up there that are rich in lithium. And that's wonderful for us. We need lithium for our electric cars. And they're rich in lithium from all the volcanoes underneath and the magmas. The mining for lithium in those areas really is reasonably simple in that they set up solar cells and they evaporate these waters to create salts. And then they take the salts and process them to get the lithium out. I didn't put a scale. That's a really bad thing for the geologist, apologies. But I would say that area is probably at least 20 kilometers, maybe 10, 20 kilometers, that length. So these are 3 evaporation cells and in a big lake. And it's a good way of mining. It produces lithium, but it takes up to 2 years to get lithium from start of evaporation to extraction. You're evaporating water in an area that doesn't have much water, and it affects wildlife in the area. So people are working down there to try and change that a bit. But if we look to Cornwall, there's a company called Cornish Lithium that's been exploring since 2016. And this is their exploration hole for what we call geothermal lithium. And it's a really interesting story. So in 1884, there was a geologist, I think with the government at the time, who was underground working with the tin miners. And for some reason, he was very interested in the geothermal waters, so the hot waters that existed underground. And for some other reason, I have no idea why, but he analyzed them for lithium. And he said, if lithium had a value, this could be a mine. And so Cornish Lithium got some funding to start exploring on the back of that, which is incredible. And they've been working ever since. So this was their exploration borehole, and they found lithium in this. And it's not huge amounts, but it's enough. And now they've been working on processing those waters. And so this would be their mine, essentially. The idea would be they'd extract the water out of here. They would process it on site in a small unit. And then they would take the leftover water, and as long as the Environment Agency said it was okay, they'd pump it back down the borehole. So this is very targeted mining. There'll be very little waste and a very small footprint. So there's a lot of research going around. Not all deposits lend themselves to this, but there's a lot of research going around to try and reduce waste and make mining much more efficient. So the next one, and I'd say this is probably the biggest issue for mining companies today. This is the one that they face, and they haven't, well, they are now, but in the past, they would hire workers and not really think about the community they work in. These days, this idea of a social license to operate, it's a term that's used, not everybody likes it, but it really means that a company ideally should be thinking of the community in which they're working. They should be engaging, they should be consulting and building trust about what they're doing. If they don't get that, you can see this might happen. And it did actually happen about, I think it was last year in Serbia, where Rio Tinto was developing a lithium mine, and we know we need lithium, and they almost got to the point of opening, and then the people in the community said, no, you haven't done enough due diligence. We're not trusting of what you're going to do. No, you can't open that mine. And it didn't open. So people have a lot of power. And so there's a lot of work going on now. Companies, big and small, are engaging with communities, trying to work with them, hire local people, all sorts of things like this to try and bring people into the mix. And it's not just local communities, it's regional, national governments, and the communities that we work with. So this is a great change. And when I say that careers in earth science and geology have changed, I work with social scientists a lot now, and I never would have done when I studied. So the range of careers has increased enormously, which is great, really great. And then the final, this is an example I often get asked by my students. Can you give me a good example? And this is a company called B2 Gold. They operate in Africa. They're quite a small company. And this is their website. So they will have all the things, but they actually do these things. They do provide healthcare facilities. They do a lot of water management. They have a nature reserve right next to their mine. So, and people have been down, my colleagues, to actually see them. And this is an example. It's not the only one. So the companies are really responding, which is great. There's other things like women in mining groups. These are our students I took out to a potential mine in Devon called Tungsten West, and, engaging with the students. These are the future workforce. So it's great for the students to see what's going on. It's great for the companies to be engaging with students. So a lot more interaction than we used to see. And then the final pillar I was going to say is safety. So safety, if you go to big mines in the West or the developed countries, you'll often see the sign saying, days since the last accident, da, 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 da. And safety is absolutely number one at a lot of mines. But I think safety in the recognition of the link with people is becoming much, much more important. And with that is coming innovation. So autonomous mining, a lot of these trucks are run from a computer. Not all of them. Some of the drills might be run by computer. And this is especially underground, where things can be a bit dangerous with gases and explosions and things. There's a lot of move to get autonomous vehicles underground. So again, opening up a new area of employment in geology, computers, AI, and so on. So there is change. I'm not saying it's all change. There's a lot of work to do. There's still examples of bad practice for sure, but the movement is got huge momentum. And I think the companies know, first of all, we need them, but we need to be holding them to account. So where do we go from here? Well, so again, I'm going to bring in business models now. So at the moment, we have what's called a linear economy in most everything we do. And in mining, that means we extract something from the ground, we produce something from it, so a battery or a car, the producer distributes that and sells it to us and other people, and we use it. And when we're done, out it goes. And I think these days, I'm not that young, but I remember my parents saying, oh, in my day, the fridge lasted for 50 years. And these days, if your fridge stops, people might just chuck it and get a new one. So things don't last as long as they used to do. So it's basically a take, make, and waste economy we have now. It's not all bad because there is some recycling. Of course, there's a lot more a lot more every year where you use and you try and recycle, and that goes back into production. It's not so new, it's been around for a while, something called a circular economy. So it's very hard to see, but the idea is that, I'll just go back a slide. Rather than dispose, what you try and do is you do a few things. You keep that use much longer. So you try and make things like they used to do that will last a long time, and you use and use until you can't use it anymore. Then at that point, you would recycle. But the change is that companies are now thinking, okay, at this stage where we produce, let's make things so they are more easy to recycle. So we actually have a project going at the moment where we're working with people in Birmingham and Leicester, and they're making rare earth magnets for cars, much better to take apart. So the glues will change. And they have better ways of shredding things, really basic stuff, to be able to get the maximum rare earth elements out of those things. And then again, you distribute and you try and keep this cycle going as long as you can. So you're trying to eliminate or reduce waste, keep things in circulation as long as possible. And then at the same time, you're regenerating nature. So those are the three principles of circular economy. So, and nature will regenerate hopefully by us not producing so much waste. So the mining industry is no different. It's looking at circular economy models. So again, trying to use waste like tailings and think of them as a resource and not as waste. So trying to reuse and remanufacture. And there's lots of ways that mining companies are looking at in putting in circular economy. So minimizing waste at the point of production, having a borehole like Cornish Lithium does, so you don't produce any waste. Cataloging waste. So when you have a waste, try and separate it into different types. So you might be able to use it for different things, either now or in the future. Working with the people that make the products. So making that link between producing the stuff, the minerals and the metals at the mine, and then the people that produce. Minimizing waste. There's a lot around waste, but thinking more in a circular way and not just thinking we're going to make waste and then chuck it away. So that's a big innovation. Not mining companies aren't the only ones doing this. There's a lot of companies trying to go this way. And I think it's in the recognition that, you know, we're being producing, buying. Let's think now about, you know, our Earth is a finite resource. And why don't we just keep reusing things within it and not just keep extracting? So the other thing that's happening is this idea of responsibility. So a thing called responsible sourcing. You may have heard of something called a blood diamond. So these are produced in Africa, and they're produced in areas where there's a lot of conflict. So the sale of the diamonds is used to fund wars and conflict. And so the World Diamond Council some time ago set up a system for responsible diamond, where a diamond could almost have a stamp or a mini stamp or a fingerprint to show that it was produced responsibly and not to support wars and so on. And this is extended into other jewelry, like gold-bearing jewelry, and even to batteries. So something coming out in the EU this year is something called a digital battery passport. And again, this is to show that the materials that go into a battery, and particularly the cobalt, because most of the world's cobalt is mined from the Congo, where there's still child labor that's used. So this is to say, we're going to follow this battery from the time it's made, what went into that battery, also then what happened to it afterwards. We know batteries don't live forever. So after the battery is finished and taken apart and reprocessed, the metal's extracted and making a new battery. So they're going to find a way to trace all of these metals, make sure they're produced responsibly, and then give that battery a stamp, like in the passport. So this is growing as well. It's a bit slow, but it's already caught on with the batteries, and I think other products you'll see it as well. So if you're interested, you can check if things are responsibly sourced, a bit like some of the food products we get. The other thing is innovation. That's certainly a way that we're going in the future. So I've already mentioned autonomous trucks. I think the other thing are robots. That's not one that's in operation, but it's a wish list one. It's rather large. But again, more automation in mines means more safety. So especially underground, getting robots to do what they can do, and then having people at computers. And this will also improve the workers' lives as well, in theory. So a lot of mining camps that are remote will have what they call a 2-week in, 2-week out work rota, where someone will fly to the camp, work hard for 2 weeks, and then have 2 weeks off. That's very hard if you have a family or you want to have a regular life. So by having automation means you could sit in Perth, Australia, have a nice life in Perth, and operate some of the mines from Perth rather than having to go to the mine. So we'll see what happens. People are worried that this might reduce the number of jobs because you won't have truck drivers. But in fact, the industry says they anticipate an increase to keep up with technology, to keep building innovation, and to run all the automation. It's just a different style of jobs. The other innovation is in the way we mine. So I've already mentioned Cornish Lithium and their borehole. Researchers, I've got a colleague in my department doing this electrokinetic mining in the lab at this point. And the idea is you have a battery, you put a current through a rock or a pile of waste, and you add some water, and that current makes metals move, and you can then recover those waters up here and extract the metals. So it's not, you wouldn't have to dig this up. You just have to pass a current and some fluids through the rock, wouldn't generate any waste, and you'd still have a product at the end of the day. So this is very early on. It's in the research stage, but that's where innovation comes. You have to start somewhere. Okay. So where are we going? I think we're going from the age, not just me, many people think we're moving from the age of oil to the age of minerals. Minerals host those metals and other elements that we need for our green technologies like solar panels, wind turbines, and so on. We do need to mine at the moment if we want to be going to the green technologies, if we want to reduce our carbon emissions, because right now we just don't have enough of these, what they call critical raw materials in circulation at the moment. I think we need to be honest about mining. We need to recognize that there are positives and negatives, and I think companies have to be honest about them too. And by recognizing the negatives, I think we can do something about them. So that's hopefully, I think we're doing that. We have a responsibility. So the mining company is trying largely to employ sustainable practices. If you look at many websites for mining companies now, you'll see they have sustainability web pages. They'll have sustainability managers and governance managers and so on. So they've really expanded what they do. But we have a responsibility, and we have a power actually to hold them to account. As investors, if you invest in the mining companies, you have a lot of influence. So we have to keep on top of them to make sure that they're doing it correctly or in the best way forward. But someday, I think circular economy will really come in. It means there's a lot more of the Earth's materials will be kept in circulation for longer in the goods we produce, and we will have more things in circulation. And also in parallel, if we can work on our desires for lots and lots of things, then maybe our demand will go down at the same time. Some people ask me, will that mean that mining will not be needed in the future? I can't really answer that. I think probably not. We'll still need new things, but the overall need for mining will be greatly lessened. And I think it'll be better overall. So hopefully we're going the right way with mining. So
well, Karen, I'm so glad you could be with us today, and what a wonderful talk you've given us, and thank you very much.